Thank you, Bruce. All right, good morning, everyone. My name is Emily Keene. I am a graduate from MIT's Leaders for Global Operations program, and I am the planning director for this year's MIMO Symposium. I have a few brief logistical announcements to make before we get started. First of all, just so you guys know, we have a few breaks scheduled throughout the day. We are on a tight schedule, so hopefully we don't get into them too much, but I'll ask everyone to please avoid leaving or entering the auditorium as much as possible while the presenters are up front. We have one exit at the front, we have two at the back. We have food available all day. We've had breakfast out. Hopefully you all were able to enjoy it. We'll have lunch out this afternoon as well as some snacks. We have water, coffee, and tea available to you guys all day. And then lastly, you can identify the symposium organizing committee by these pink stickers on our name tags. Please feel free to ask any of us any questions that you have about the event that we can help with. And with that, I would like to take a moment to introduce our first speaker, Paul Baldassari. Paul is President of Manufacturing and Services at Flex. He is responsible for driving global operational strategy and execution, maximizing leverage of Flex's worldwide footprint, scaling manufacturing technology, and managing responsible, sustainable manufacturing and logistics services for the company. In his 24 years with Flex, Paul has held multiple leadership roles in IT, program management, operations, and company-wide Lean and Six Sigma initiatives. Please join me in welcoming Paul to the stage for his presentation on impactful AI deployment on the shop floor, a manufacturer's approach.
Thank you. I'm very excited to be with you here today to talk about impactful AI implementation in a manufacturing world. When I arrived here yesterday, I remembered my last visit to Boston. I was running the Boston Marathon. And not too far from here, there is something called Heartbreak Hill. For those of you who ran it already, you probably remember that. You're about 3 hours in a marathon, so you did a lot of repetitive movement. And at that point, you really have to remind yourself that you're doing this for fun. It also resembles sometimes the work on the shop floor, right? You do something very repetitive for a long period of time, sometimes 8 or 12-hour shifts, and things become really difficult at that point, right? So what I want to focus on today is how can we, with AI, help our shop floor workers to produce better quality, but also improve the workplaces and make actually work more fun. So a quick introduction about Flex for those of you who may not know Flex. We are a contract manufacturer. We do a lot of electronic manufacturing, but also plastics and metalworks, and we produce the full devices and ship that many times to the distributors or directly to the customers. We operate in automotive, so we do brake systems, engine control systems, but also the other systems for autonomous cars. In medical, we produce blood glucose meters or the patches that people use now. We also produce the electronics for CT, MR, ultrasound, blood analyzers, and so on. In industrial, we do a lot about sustainable energy, so inverters, as well as energy grid systems, industrial controls, as well as semiconductor equipment. In lifestyle, we do a lot around floor care, coffee machines. Many of you use those. And in consumer, we produce cell phones and chargers and so on. And last but not least, we also do enterprise computing. So we do backend switches, everything that empowers the internet, including cell phone base stations, everything that goes into a data center, including actually AI hardware. And that's one of the areas in business that are growing for us really fast. Cannot be specific about numbers. We're going to announce our FY24 results tomorrow, but basically it's very interesting when you're on both sides, right? You're using AI, but you're also providing all the hardware to empower all the different AI solutions for the big providers. We were looking in depth about 3 years ago into our technology strategy. So what is most impactful from a technology strategy? And many of you have knowingly or unknowingly contributed to that because we've taken a lot of stakeholder feedback We also ran a couple of surveys and did a confidential survey. So you may have contributed to our technology strategy without even knowing it. And we came up with 4 areas that we see most impactful. One is digitization, making sure that we have a clear digital representation of each factory that helps us first in the product introduction process, that we can show our customers how the manufacturing line will actually work, so we can visualize, as well as we simulate on different logic layers. So we simulate the product flow, the people flow, as well as, for example, yield prediction. So we can see if we are able to achieve certain yield during the manufacturing process, what will be the impact on repair, how to optimize the process, and so on. And that is really important from 2 different areas. One is it forces in the beginning of a program that you have a common understanding of a lot of details that normally you would not be aware of, and upfront make sure that you have a clear understanding what is important for the manufacturing process. And second, you can then optimize during manufacturing without having to change the physical process. Changing physical processes is always expensive, but it's even more difficult in regulated industries when you have a qualified line, for example, in the automotive business or in the medical business. The second part is digitization. We have a lot of data coming in, and how do we make sure that we utilize the data to transform it information that our people can act on? And that's where AI plays a very important part. Third, automation. So that's not only the automation of physical processes that takes away a lot of strainers and sometimes unsafe work from our people, but also automating a lot of decision making. And again, here AI plays a very important role. And last but not least, additive manufacturing. We deploy additive manufacturing today on prototyping, on fixtures and jigs and so on. Less in volume manufacturing. That's still something that I would like to see more, but that's something that still needs advances, I would say, in solutions on additive manufacturing. So if I go into the different opportunities for AI, a lot of what's happening on the shop floor is visual management. And quality is becoming more and more center of that solution. Today, the manufacturing process for these large, for example, AI boards is really complex. The parts are getting smaller and smaller, and the assembly process becomes very, I would say, very challenging for the operator. If you think, for example, of an ADAS system for an autonomous car, many of those systems have 10 to 15 electronic boards inside, and very complex mechanical assembly as well. And imagine you're an operator and you have to assemble that all day long, and you have a couple of thousand components, and you must not forget any cable or any connector or any screws and so on. That becomes increasingly difficult for an operator to perform that on the quality levels that are required. And here AI plays a very important role. The second part is on efficiency. Each year we have to do roughly 10% more activity. So we're placing 10% more components, and we have to do that with the same number of people, because the labor market in the US, but in most other economies, is limited. And last but not least is empowerment. In Flex, we employ 160,000 people. Many other companies have a large number of people as well. If you try to centrally optimize the manufacturing process from a central team or from headquarters, you're going to fail. You will not be fast enough, and you will not understand the problem in detail to provide the right solutions. So you really need to empower the people on the shop floor to come to the right conclusions. And again, here AI plays a very important role to take that vast data that is available on the shop floor and transform that into information that people can take fast decisions on that have a meaningful business impact. If we look into our approach on AI applications, we spend most of the time actually in analyzing the problem. Many of you have used the 5 whys in Lean and Six Sigma to have a real deep understanding what you need to improve and what is required to make a meaningful business impact. And sometimes the solution may not be AI. So we go in solution agnostic, right? We don't want to preempt that we need to implement AI. So sometimes it's a very simple solution, but many times it requires something that is more complex to tackle, and then AI comes into play. Next one is data, making sure that we have the right data sources and the right data quality. And I'll talk that in the next slides. While we have a lot of data, many times it's not the right data or not the right data quality that we need to implement a meaningful solution that can sustain. Then is building of the model and making sure that the model is being sustained and supported and optimized, because many times the environment changes over time. Customers introduce new design features. We have engineering change orders. We have changes in environment, or we have changes in the supply base. We get different component lots and so on. So we need to make sure that the model is flexible enough and we continue optimizing the model throughout the lifetime. And last but not least is ensuring the business outcome, making sure that what we try to solve, we have resolved, and there is a positive business outcome that serves all the different stakeholders. So when we start with the problem, we look into what are the objectives, what are the KOIs that we want to improve, identify all the different stakeholders, and you have the obvious stakeholders, right? You have the engineering department, the finance department, but it's also the customer, the supply base that you have to involve, and most important, the workforce as well, to make sure that you engage people in your solution mapping and people continue to utilize that and continue to optimize the solution. And last but not least is to assess your data and make sure that you have the right data sources. And over time, you may identify additional data sources that you want to incorporate in your model to have the optimal solution for your shop floor. If you go into the data collection, we start with comprehensive sampling. So making sure that we cover all the different areas of conditions that we may see on the shop floor. And that sounds trivial, but it is actually very difficult because you start with a data set maybe from one factory. So we try to get data sets also from other factories that are doing similar solutions. We try to get as well with some of our competitors and see if they have data sets that we can collaborate on to make sure that we have the right data to train our model from the beginning. Have a balanced data set. Many of the conditions don't show up quite regularly. So some of the failures only happen in very specific conditions. Or you may even have to create a data set. You were talking before, Bruce was talking before about creating some specific data. When you go into a FMEA, see what other failure modes may be possible and try to create those failure modes that you have the right training data. We've seen it a couple of times that we have, for example, vision systems, and something that was described in the FMEA appeared finally. We never had it in the training set, and the system actually did not recognize that failure mode. And we had bad parts going down the manufacturing line, or worst case, even getting that to the distribution or to the customer. High quality imaging. Many times on the shop floor, you have not the optimal conditions, right? So you have light reflection, you have all kind of issues that disturb the model later on. You have changes on the shop floor, right? You're changing the manufacturing line next to, you have building changes and so on. Or you want to use your model later on in a different factory. So we saw that it is very worthwhile to invest time and money on optimizing the imaging that you get for your training data, as well as then for your actual solution implementation. Annotate data and stakeholder considerations. So a lot of the data is confidential. A lot of products that we produce are not even on the market yet. So we need to work closely with our customers and design teams and so on to make sure that we have the right usage of data and the right to use the data. From data handling and model building, so the data processing is a key part. Selecting the right model and the model training is a continued task that we have on the shop floor that helps us to ensure, as I said, to have the flexibility when things change, that the model still works on the shop floor, and that the users, the people on the shop floor, actually have the means as well to detect errors and optimize or fix those on the fly. If you always have to wait for the IT department or for the designer to come back and fix the model, that is way too slow. Yesterday, I was in one of our factories on a high-speed automation line that has a lot of image recognition systems. Even an error that shuts down the line for 3 minutes is taking a lot of volume over the day if we have several of those shutdowns. So the lines are today optimized that they avoid those micro shutdowns or micro stoppages. And we train and have the people trained on the shop floor that they can fix those errors immediately. And if you multiply a 3-minute shutdown times 20 times a day, and if the line has consecutive manufacturing and you have 50 stations, your output goes pretty much to zero if you don't tackle those problems immediately or avoid them at all. From setting up the full system, we focus on the data acquisition. Like I mentioned, the quality of the imaging, the other data sources, right? Other environmental data that we get in from temperature, humidity, voltage that we have on the power lines, everything else that we can add as well, and where we see correlation with stability of the system. I just recently had a line where vibration was, for example, a big topic. So we measured now vibration and included in our detection as well. And then the feedback devices. So making sure that the feedback that comes out of the solution is highly visible and easy to operate for the users with. So have the usual end-on lights or direct messaging to handheld devices that people use on the shop floor. Then for the model training, get everything into the AI platform. And for the actual usage on the shop floor, Bruce mentioned it before, ChatGPT, the speed for humans is good, but for a manufacturing line, it's way too slow. So you need edge devices to help you have a direct feedback to the manufacturing line and to the operators. In many cases, we have fractions of seconds for the image solution to make a decision if to continue or if to take a part out of the manufacturing line. So what are the considerations throughout the process? We always start with what do we want to achieve? So understand the problem, calculate the ROI, so making sure that it's a worthwhile solution. There are so many opportunities that we can do today on the shop floor. We have to make decisions. What do we focus on? And at the end, it's a financial decision. Where do we get the most benefit out for our stakeholders? Second, change management. So making sure that we include all the stakeholders and we have a lasting solution. We worked with RedCef on that in the past. Looking into the 3 lenses, so from a process perspective, from an organization perspective, and from a culture perspective, how do we implement AI in an impactful way? And last but not least, the employee buy-in. And when you include the employees right from the beginning in the solution mapping, as well as in the training, and they feel that they are part of the solution and it's their solution and they have a way to actually influence the workplace, then you get buy-in and you get engagement and you get a very good business outcome. If people feel there is something being put on top of them that potentially can put their job in danger, then you get into a very different environment and you get a lot of pushback. And we operate in many different countries, right? We operate with unions, with work councils. We always found a good way when we show people how we can take repetitive and strenuous and boring activities out of people's work, and we empower them to make their own decisions and to make their workplaces better. Then We have buy-in from all the different stakeholders, and we get real good usage and real good outcomes, and that feeds back into ROI. So at the end, we create win-win situations. It is more work, right, than putting just a solution in front of people, but it's absolutely worthwhile if you look into the three lenses and you make sure that you have everybody's buy-in, then you have a lasting and sustainable solution. So with that, I want to share two case studies that we've implemented. These are examples of many things that we've implemented on the shop floor so far, and many more to come. The challenge is for us to reduce critical defects on the shop floor. I mentioned before, we have these high complex assemblies with a lot of electrical and mechanical parts that go into risk applications, right? If you have a motor control system or even a braking system or an autonomous car, this application needs to work, and you cannot have any defects out in the field. The production lines have become way more complex, so we see way more stations, as well as challenges with designs that are not completely ready yet for mass manufacturing. So if you have a yield of 98%, but you have a lot of different stations and each station has 98%, your output is still very, very low. And with AI, we are able to increase that yield dramatically during the product introduction process. And then the pressure on human workers to accurately perform that over a long period of time. When you stand on a workplace and you do the same task for 10 or 12 hours and you do, for example, vision inspection, you get tired over time, right? And the chances that you miss a screw or a cable or whatever becomes pretty high. And if that goes over multiple different stations, again, you have the challenge that the output and the quality of the end product decreases dramatically. So what we do here is we work with image classification, object detection, and image segmentation that helps us to detect objects that are missing, for example, screws or cables or whatever are misplaced or are during the assembly process damaged or misplaced, or if any solder joints actually have issues, as well as if the mechanical assembly has issues. And I'll show you in a second the outcome. So on the two examples that I've brought here, we had huge ROI. So we had improved the yield by 97%, and we had less than 6 months payback. So seldom the question is, does this solution actually deliver a financial benefit? It's more like, how many different things can I do at the same time? And that's where we use the ROI for, to make sure that we have the right priority for implementing solutions, and with that, assigning resources on the shop floor. And the other one is where we have a sheet metal assembly solution. We put a solution in place that also drove 28% efficiency improvement and 300% return on investment. So I'll show you a quick video. Basically, that solution provides vision inspection and records all the different images as well later on if there are any quality issues. And you see here already, the camera moves from all different angles. It's a pretty large assembly with a couple of different boards. So if the operator would have to move around, that would be quite difficult also to see it from all the different angles. Plus, the additional advantage is we are recording all the images. So if we have later any other failure modes that we need to detect, we can use that same database to see if there were any failures in manufacturing before, or we can prove if there is suddenly something happening that previous products produced were actually okay, and we can avoid recalls. With a human operator, this would not have been possible. As well, the workplace where you run around and you check all the different parts for 10 or 12 hours a day is actually pretty terrible. So in that case, we can take away what's kind of repetitive, strenuous, and tiring, and we have a better outcome from a quality perspective as well. What are the learning elements for success? We focus on scalable solutions, leading back to accelerating the impact. So when we define those solutions, we try to make them as flexible as possible that we can roll them out on multiple different workstations. As mentioned, right, we have 160,000 people. There are many visual inspection places, for example, today, but also many assembly stations where part of that requires also visual management. Continuous learning, making sure that we get feedback from the different stakeholders, especially the operators. And we've implemented a long time ago as part of our lean manufacturing system, these small group activities where people can come together and can take different functional know-how pairs and put them together in a project to actually improve those processes or solutions. And we feed that back to our global team that we can deploy it all over the world. Integrate in real time into our other digital manufacturing landscape. So feedback all that information back into our shop floor control system and make that accessible across the globe that other sites can benefit as well if we have innovation or findings or quality alerts across the globe. And last but not least, the user interface. So we make all of that available on the smartphone or tablet, or where that's not possible, they have at least an Andon light that people have an easy access, right? My career started in IT. In the beginning, I did not focus so much on the user interface, right? A black screen where you had to press a couple of different keys to get to the next screen was good enough for me. But I realized over time how important it is that the user interface is intuitive, that people can actually, regardless of their background and of their experience, intuitively use those solutions and make a meaningful business impact. And it helps not only them to have better work life on the shop floor, but also us from a quality perspective and from an ROI perspective. So finally, if I can highlight 3 areas for impactful AI implementation and how to accelerate it across the manufacturing company. It's about the deep understanding of the problem. We spend most of our time now understanding the problem, and we don't start with a solution first. We don't start, we want to implement AI, but we start to understand the problem, what's going to be the solution that's going to be most impactful and best for the employee on the shop floor. And in many cases, it turns now out that it is an AI solution. Have the right business and operational metrics. So record from the beginning, where are we today? Where do we need to go? And continuously check that afterwards. We do our post-mortems afterwards. And sometimes you don't reach what you wanted to reach. But being open about that and learning what went well and what did not go well helps you later on in your next project to be more successful. And most important, to be employee inclusive in your implementation. Making sure that the people on the shop floor are included in developing the solution from the beginning, have a clear understanding how they can influence, how they can utilize, and how that improves their operation, their day-to-day work, and get all their feedback to help you learn and scale on a global basis. Thank you. We have a few minutes for Q&A. Any questions? Please.
Everyone hear me? Or should I go to the mic?
I hear you well.
Okay. So I was curious. So I'm with a startup. We're working on automating sourcing to mitigate supply chain risk. It was a really interesting talk, and I really appreciated the focus on the problem identification and inclusion piece. I was curious where in this process you reason about the build versus buy decision when it comes to the actual machine learning systems.
So on the machine learning systems, we normally buy that. We hardly do any machine learning solutions ourselves. So as soon as we have the problem identified and we understand what data set we have available, we look into what model we can use, and most likely there is something available already on the market. And on the other part that you mentioned, right, that you're working in the supply chain, that's also really important. Many times our shop floor issues come from variations in the supply chain. When we get new lots, components change, parameters change. With the complexity in design, tolerance stack-up is a huge issue in manufacturing today. So involving the supply chain is really important as well. And sometimes the solution is an AI solution with the supplier or in the supplier's factory rather than our factory. Thanks.
So just to build on the last comment that you made that you mostly acquire solutions from the outside. So as someone that probably is being approached quite a bit by offerings of AI solutions, could you maybe share some perspective of what works for you, what doesn't work for you? What would be your advice to people that try to develop solutions to customers about how they should think about what they're doing?
That's a great question. Thanks you, Recep. Many times we get people that come and show us how great the model is, how great their engine is. Yeah? And I always give the example then, it's like, you know, someone asks for an Uber because they want to get from A to B and you sell them a combustion engine. The actual user is not interested in the combustion engine. They're introduced in a car with a driver that can get them from A to B. And by the way, if you offer them a better way with an underground or a train or whatever else, they would take that as well. So think about the problem statement and the KOIs before thinking about your technical solution. In my case, if you can offer me a solution to a problem that I have right now and that makes the work life of the people on the shop floor better, I'll buy it immediately. But if you tell me you have the greatest engine, I don't know what to do with that because I still have to get from what I need to improve to how do I sustain that on the shop floor in a meaningful way. Thanks.
Hi, thank you for your talk. My name is Ben Linville-Engler. I work for the MassTech Collaborative. It's a state economic development agency, and we support manufacturers across the Commonwealth who are all starting to be interested in incorporating AI and machine learning into some of their work. Some are small manufacturers, some are large companies like yourself. And I was curious if you could elaborate a little bit more on sort of the second order, like organizational impacts that you talked about. For example, you know, if products or processes are changing, model maintenance and including that as part of the life cycle seems to be important from what you described. But then also, you know, how does it impact record retention when you've got tons of high resolution images that you're capturing through some of these systems? I'm just curious if you've got examples or anything you could share from those two aspects.
Yeah, so we do store a lot of information, right? And if it's images of products, that's normally not a big deal. If it's people recording people that actually perform work on the shop floor, you need to be very careful about privacy and data privacy laws and so on. So we are very careful on that. And especially as we operate in the European Union with shall I say, very, very specific data privacy laws, we have incorporated that. From a record retention, programs change fast, right? So normally when a program ends, we take all the data, we ask our customer if they would like to keep a backup or if we should actually dispose of that and make sure that no confidential information gets leaked later on. So we have a record retention perspective from that as well. And then keeping information for our own model development, we try to abstract as much as possible that we get out of any proprietary information and take that information for future optimization of manufacturing processes. For example, placing electrical components on boards. We have today a rule set of 6 million rules that we have taken or generalized them in a way that it's not connected to specific customer proprietary information anymore, and we store it in a separate model. Did that answer your question?
Yeah, I guess just the other one is, you have like people that connect into the manufacturing team as processes are changing to do model maintenance, or like in terms of software engineers, or how does that aspect work in terms of continuous improvement or updates?
Yeah, so we have our IT and our OT team that work closely together to support on the shop floor on model maintenance. And we have so many changes because today on a normal product I can give you one number. We have 800,000 engineering change orders a year that we have to process, where form, fit, or function on the product changes, right? And we try to make the models in a way, I mentioned before, that they're flexible enough that we don't have to change the full model if something changes, positions change, and so on. But if there are significant changes that need model maintenance, then the operator can connect with OT and they connect with IT to make that change.
Yeah. Very interesting, Paul. Thank you very much. Vijay De Silva, Senior Lecturer previously at McKinsey. And I love the focus on business impact. And I wanted to go back to where you started, right, around the marathon and Heartbreak Hill. And these never typically happen in a straight line. And so what were some of the challenges that you didn't anticipate that held you up during this process?
The challenges that we see through the process are stakeholder involvement. So we sometimes see that we have different competing interests from stakeholders and different maturity as well on usage of AI solutions. So making sure that we include the full supply chain as well, especially suppliers that are critical on mechanical components or electrical components, get included as well. Because when they change, that has huge impact on the rest of the model and the assembly. Yeah? And with that, I think we get better and better in integration on fast tracking, on boarding them. But that's something where we still do struggle a little bit, especially with suppliers that are, shall I say, that are smaller, not used to AI deployment, and have the expectation of the flexibility of a human, right? Humans are super flexible on the shop floor, right? They can take whatever. You can provide smaller, bigger parts. They will find ways to assemble it. Yeah. Sometimes you have to actually hold them back a little bit, right? That they don't get too creative to make the product work, because that can cause issues later on the shop floor. An automated solution, an AI solution is not that flexible. So getting back to that transparency and integration in the supply chain is still something that we need to tackle.
Thank you.